Hey everyone, so this is day 2 of completing the square. So pause the video and do these solving quadratic problems. So the first one we have 64, I'm turn the pen on, 64x squared minus 100 equals 0. You could actually divide that whole thing by 4. If this was a factoring problem, I would definitely require that. 16x squared minus 25 equals 0, because we're dividing both sides. So 4x plus 5, 4x minus 5 equals 0. So x is a negative 1 over 4, and x equals, did I say 1? 5 over 4. The next one, we need 0 on one side again, so I'm going to move the x squared to the other side. X squared plus 5x plus 6. It's a trinomial, nothing in front of x squared. So we're looking for two numbers that multiply to 6 and add to 5. It's plus 2 and plus 3. Set each of those equal to 0, and we get negative 2 and negative 3. And then the last one, I'm going to add 2x squared, so that gives me 3x squared, minus 5x, minus 23x plus 14. Alright, so this is a slide or do it in your head one. Let's see. My guess, oh, it's 7 and 2. Alright, 7 times 2. If I put a 7 here, that gives me 21. Plus 2 is 23, and they are both negative. Set each of these equal to 0, and we get x equals 2 over 3, and x equals 7. Alright, so what does it mean to complete the square? So remember from yesterday, it's writing a quadratic as a perfect square plus or minus a constant. So usually I write it as it's x minus h squared plus k. Right? And then sometimes you can have an a in front too. There is a number in front sometimes. So it's writing it in this form. And the reason we do this is because for graphing and solving purposes, if you can't factor, you need another way to solve. So tomorrow's lesson, we're going to be talking about solving. But today we're just practicing the completing the square. All right, so pause the video and try these two on your own. So remember, we take our 6, we divide it by 2 and get 3. We then square that and get 9. That's the number we want in the problem instead of that 5. Right? That 5 is not going to help us make a perfect square. By putting a 9 there, that means we can factor it, x minus 3, which is x minus 3 squared. But remember, you can't just magically put 9 into a problem. So I add it in, then I also subtract it, and I combine that with negative 5. So these 3 are my x minus 3 squared, and then I combine those out, those two numbers, minus 14, and that's my outside number. And then this one, again, same idea. Take our 14, divide by 2, we get 7. 7 squared is 49. That's my C term. That's the term I want in the problem. X squared plus 14x plus 49. Because when I factor that, that gives me x plus 7 squared. Now, there's two ways to think about it. I added 49, so then I subtract it and combine that with a 2, right? That gives me my outside number. Another way to think about it is I have 49, I need to get to 2. How do you get from 49 to 2? You subtract 47. So you can use the logical method, or you could just say, oh, I added it in, now I subtract it and combine. All right, these are slightly different, but same process. So what's the problem here? We have a coefficient. You cannot complete the square when there's a coefficient. So we're going to do a GCF of 2, and over here a GCF of negative 3. So divide those out and then complete the square. Pause the video, try it on your own. When I divide, I get x squared plus 10x minus 5. And then same process as before. 10 divided by 2 is 5. 5 squared is 25. So x squared plus 10x plus 25, which gives me that binomial squared. Now I added 25 in the problem, so then we subtract it and combine it with that outside number. Put those together, we get negative 30. Now here's the problem. Excuse me. We have to put the 2 back in the problem. A lot of students do this. They just put the 2 in front. This is not the answer. Wrong. Because we divided the entire thing, the entire function or expression by 2. So it has to go back in the entire function. So we're going to do 2x plus 5 squared, but then also minus 60. We have to multiply the 30 by 2 also. That is our final answer. All right, so we divided by negative 3, and we get x squared minus 40x plus 100. 40 divided by 2 is 20. 20 squared is 400. That's my C term. So x squared minus 40x plus 400 is my perfect square binomial. X minus 20 squared. Now, how do you get from 400 to 100? You subtract 300. Or again, I added 400 in, so then I subtract it and combine it with the term they gave me. Right, that term goes right there. And then we have to put that negative 3 back into the problem. So negative 3, x minus 20 squared plus 900. All right, so now the next ones are a little trickier, but we can do it. So notice this process I keep writing down. And a lot of students can do this in their head, which is great. But I like writing it down to kind of remind us what we're doing, because sometimes kids don't really think, they just kind of know it. They don't really think about the process on how they got it. So we divide by 2, take the middle term, divide by 2, and square it. Middle term, divide by 2, square it. That's find that pattern. Because these are more difficult. Because what happens when I take the middle term and divide by 2? 9 divided by 2 is a decimal. But it's easier to leave this as a fraction. We're going to leave it as 9 over 2. Then I square it. 81 over 4. So my trinomial is that. Take the middle term, divide by 2, square it. That's my C term. When I factor that, I get x plus 9 over 2 squared. Right? Because 9 over 2 plus 9 over 2 is 9. Right? Half of something. And then we added 81 over 4. So then we have to subtract the 81 over 4. And we have to combine that with negative 2. But we have negative 2 over 1. We want a common denominator. So the common denominator is 4. Whatever I do to the bottom, I do to the top. So that's a negative 8. Put that together, negative 89 over 4. So I know these are a little scary, but they're really not that bad. Do not use a calculator. You can use your brain on these. All right. Pause the video. Try 6 on your own. So we have 15 over 2, and then we square it. 225 over 4. Notice I don't worry about the negative because we're going to square it anyway, so it doesn't matter. So x squared minus 15x plus 225 over 4, which is my x minus 15 over 2, quantity squared. So now I added 225, so then I have to minus the 225 over 4, and then combine that with negative 16. 16 over 1, my common denominator, it's a minus again, is 4 times 4 times 4. So they're both negative, so we can add them together. So negative 289 over 4 is our answer. So in both of these, notice, all you do is you take your B term, 9 divided by 2, 15 divided by 2. I'm going to start skipping steps because Showing like all the work is annoying. All right, same process again. We have a GCF again. So let's take out the 2. X squared plus 5x minus 9. All right, pause the video. Try this one on your own. All right, so I know my binomial is going to be x plus half of 5, 5 over 2. So I added 25 over 4 into the problem. Subtract it, minus 25 over 4. And then I need to put that 9 in there. 9 times 4 is 36. So this is me skipping the steps. X plus 5 over 2 squared minus 61 over 4. So notice I kind of just jumped right into my binomial. And then I had to, within that, we added the 25 over 4. So over here we subtracted it and combined it with the negative 9. Now we have to put 2 back into the problem. So we multiply it by the front. 2 times x plus 5 over 2 squared minus 2 times 61 over 4. I'm going to do it up here. So when you multiply, this is really 2 over 1. What I did was I cross-canceled. 2 goes into 4 twice. So I end up with 61 over 2. And that is my final answer. All right, try number 8 on your own. Pause the video. All right, so we're dividing by 5. X squared minus 3x plus 16. X minus half of 3, 3 over 2. I have to subtract off that extra 3 over 2 squared, so 9 over 4. 16 times 4 is 64. So we get x minus 3 over 2 squared plus 64 minus 9 is 55 over 4. And then last we put our 5 back into the problem. 5 times x minus 3 over 2 squared plus, now we can't cross cancel this time, so we just have to do 55 times 5, which is 275 over 4. All right, so I think these are very doable. The next one is the hard one. All right, so this is as hard as it could possibly get. All right, you ready? We can do it. All right, again, we have a GCF. We have a number in front of 4. Sadly, though, when I divide it out, that 7 isn't going anywhere, right? So it's x squared plus 7 over 4x minus 4. So this one's tricky. My binomial, I have to do 7 over 4 divided by 2. What is 7 over 4 divided by 2? When you take a fraction and divide it by a whole number, you just end up multiplying your denominators together. So it's 7 over 8. Think of it like if I have half a pie and I divide it in half, I now have a fourths of a pie. 1/2 times the 2 and the 2 multiply. All right, so we got that in there, and then we added in the square. Now we have to subtract it. So 7 over 8 squared is 49 over 64. And this is where things get tricky because I have that 4 over 1. So to find the common denominator is 64. So I have to do 4 times 64 to find to make that fraction. Let's see, it's 16 to 56. And then combine those together. X plus 7 over 8 squared minus, let's see, I haven't actually done these yet, so where I'm adding that to 5, carry the 1, 305. And then last step, put the 4 back into the problem. Now this one, the 4 does cancel into the 64, so I'm going to make this 305 over 16. And that is the answer. All right, pause the video. Try 10 on your own. You can do it. I have confidence. So I'm going to take out that 3. X squared minus 8/3 x plus 11 over 3. This is basically as hard as it would get. I guess I could make it harder with bigger numbers, but this is difficult enough. X minus, remember we take our middle term, 8/3 divided by 2 is 8 over 6, which is 4 over 3. I'm going to simplify it. So we have an extra 4 over 3 squared in the problem, so we subtract it. 16 over 9. Then I have to take my 11 over 3, combine that in there. I want a common denominator of 9. So 3 and 3, that's 33. Combine these together. This one actually is easier. X minus 4 over 3 squared plus 17 over 9. We're going to take that and put the 3 back into the problem. So we get 3 x plus 4/3 squared plus the 3 cancels out with the 9, and we're left with 3. That is your final answer. So it's tricky, but definitely like those numbers were small. That's a doable problem. All right, that's it. Have a fabulous day, guys.